Hello and welcome back to another video. In this problem, we're asked to find the numbers at which f is discontinuous, and at which of these numbers is f continuous from the right, from the left, or neither. We're also asked to sketch the graph of f. So first of all, let's sketch the graph first, because that'll help us visualize what we're actually trying to do here. So we have a piecewise function with three pieces. First of all, x squared if x is less than -1. If we imagine the parabola, right, we draw it in and it starts at x is equal to -1. Open circle because it's not equal to -1, and then we can draw the parabola as so. Next, we have f of x equals x from -1 to 1, from here to here. So we start at -1, -1, and we go to 1, 1. And since it includes -1, we fill in the circle. And finally, we have the function 1 over x if x is greater than or equal to 1, which we know goes like this. It hits this point, and then that's our starting point at x equals 1, and then it approaches 0 as we go to infinity. So if we're looking at this, we can see one discontinuity, which is at x is equal to -1, the function is continuous only from the right? Because as the function approaches -1 from the right, it approaches the value of the function at -1 itself. However, that's not the case from the left. So that's what we should expect to find from our math. And the way we think about this is we have three functions here. X squared and x are polynomials. 1 over x is a rational function. And from theorem 7, we can state that these functions are continuous over their domains. So we know that it is only at the points where we jump from one function to the other where we have to test continuity. So that happens at -1 and at 1. So at -1, we have to test the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and f of 1. And then we also have to test it for -1, approaching -1 from the left, the limit as x approaches -1 from the right, and f of -1. So we can use the fact that from the left, that is values that are less than 1, so we're going to be using x squared. And we don't have any domain restrictions here, so we just straight and plug in the value. And excuse me, I'm starting with 1. So we're looking at values that are less than 1, but approaching 1, which means we're actually going to use x, right? Since it's between -1 and 1, right? So as we're approaching 1 from the left, we're going to be using f of x is equal to x. So we just plug in 1, no extra steps there. Approaching from the right, it's going to be values that are approaching 1 but greater than 1, which means we're going to use 1 over x. So the limit is equal to 1 over 1, which is 1. And f of 1 is the same as the limit as x approaches 1 from the right. We're going to be using 1 over x. So 1 over 1 is 1. Therefore, the limit as x approaches 1 of the function equals 1, because the limit from the left and the right equal each other, and this equals f of 1, so therefore the function is continuous at that point. And for -1, the limit as x approaches -1 from the left, this is value smaller than -1, so we use x squared. So this is equal to 1 squared, which is 1. From the right, that's a value is greater than -1, so we're going to use x, so plugging in -1, it's just -1. And f of -1, when x equals -1, we can see from here that we use x, so it's also -1. Therefore, the limits as x approaches -1 does not exist because the limit from the left and the right do not equal each other. And therefore, we can say that the function f is discontinuous at x equals -1. And we can see that the limit as x approaches 1 from the right is equal to f of -1, and the limit from the left is not equal to it. So we can say that it's continuous from the right.